All right, so we've already done a ton of square roots, so I figured I would really up the ante. We've also dealt with our constants in the last two examples, so I just was like, let's clean it up and make it simpler. No constants running about to cause us any trouble. Let's just look at a BPNF problem on its own. So what would this look like? Oh goodness, I don't even know if this will work with a conjugate. Ooh, I'm excited. Let's just see what happens. I might end up getting myself in too much trouble. I might need square roots. We'll see. So if we're going to do this with the power rule, we would sit there and we would go, right, well, let me rewrite this as a rational exponent. We know for writing rational exponents, the index on our radical is the denominator. The power or exponent on our variable is the numerator of our rational exponent. So that's how we can move there. And now we can see our sweet, sweet power rule. And if we wanted to do our derivative, we're going to bring that 3/4 down and then, get really good at subtracting 1 from fractions to find that this is equal to 3. Come on. She's been slow. 3/4 and then x to the negative 1/4. Cool. And then if you really wanted to, I guess you could rewrite this as 3/4x to the 1/4. If you wanted to get really into, going back to sort of the format this was given in, you might even go to 3/4 to the 4th root. Come on. Of x. You might recognize, we talked about in class, that this technically isn't simplified by kind of math standards. We don't like to have radicals in a denominator. It's a holdover from like when people use slide rules and books with tables to do square roots and cube roots. But if you want to be good about it, you could multiply top and bottom by the 4th root of x to the 3rd. This way you end up with 4th root of x to the 4th in the denominator, and that 4th root and 4th power cancel out, or they become 4 out of 4, which is 1. And so your final answer to this, these are all final answers as far as I'm concerned, is this nonsense. I lost the 4. So every single one of these to me is an answer that you could have stopped at, like just depending on what format you like best. That they're all the same, they're all equivalent. Don't go further than you need to go in any problem unless it tells you have to. This is a great conversation that Matt and I had, I think, last class, which was, don't, if it doesn't say distribute out all that crap, stop right away. So let's see. This may end up being a video of my failures because I didn't think through whether or not I knew algebraically how to deal with this difference quotient. I was just really excited about the power rule. So this might be a really good demonstration of the power rule and some stuff related to radicals with a failure on the limit notation. But you know what? It's better to be curious and try things and break them than to not be curious. And so I'm gonna model my own curiosity. I am going to tell you that I might end up in too deep of a water for myself, but we're still going to try. So this time, based on the amount of space I have left, I am not going to write your difference quotient. You've already watched 2 videos, hopefully, with me writing out that difference quotient. You don't need it again. So here's where I'm terrified. I've got this 4th root, which I don't know how to get rid of x plus h cubed. Oh god, that's horrible. Oh, why did I make it a cube in there? Minus the 4th root of x cubed all over h. So sure enough, I plug in h0, I'm going to get 0 over 0. I am regretting all of my life choices at this point. Let's try the conjugate, right? I mean, heck, I don't know. Conjugates typically come to the rescue when we do radicals. I don't know that I've ever suffered through them on anything this gnarly in my lifetime. But maybe. I'm the type of kid who would have tried to break this back in high school, so maybe I tried to do this. Oh, and it's gotta be conjugate, Kelly. Conjugate. I'm so nervous that I can't even write my conjugate properly. Alright, you know the drill. Okay, we're multiplying by all that nonsense. Change the minus to a plus. That's the conjugate. We're going to leverage our difference of squares here. That's what the conjugate gives us. And I'm already sad because the result is not going to work for me. Let's see why not. Is there any way I could have fixed it? I don't think so. Anyways, let's just see. I'm already feeling immense failure, but I'm going to do it. I'm going to do it. Okay. So if I multiply the first two terms together, the difference of squares is great when you have squared things. When you have things that are the fourth root, they're not so useful. Because right now I have the fourth root of this hideous ass thing squared. I mean, I could rewrite that's 6/4. Could I make it better? Oh my god, I might go down a rabbit hole. Feel free to just bail now. But I'm seeing something I think might be helpful. Minus, and then we have our fourth root of x to the third squared. So in my brain, you don't want to be in here, but in my brain, what is happening is I'm thinking about those rational exponents. I know Justin and Austin love those rational exponents. I've seen their board work. So I'm thinking about this and I'm going, well, this was 3/4. And now I just multiplied it by, I just added that square. So really, when you take it a power and raise it to another power, you're multiplying by 2. So this is now 6/4, which is 3/2. Okay. So I could rewrite this numerator. I'm just going to write down a mess down here because I'm worried there's going to be a lot of work, so I'm not going to rewrite it every time. I will be good and rewrite my limit notation. But I'm going to rewrite, and again, please bail. Don't continue watching this, but I am excited. I'm going to try out now rewriting this as the square root of x plus h cubed, right? Because I can reduce that index because I've squared it. It's like kind of the magic thing. I can just leave the 3 alone. This is 2/4, which is 1/2, which is just a square root. And I can do the same thing on the back end. I've got this nonsense with just a square root. I know what the mess is. I just don't want to write it. So we have our mess at the bottom. Now, perhaps a conjugate again. You know, it's good when I'm having fun. And I really, this is something that's wrong with me. I have fun when I do math. And I realize that sometimes it's not fun, but you gotta not worry about being wrong and just start doing things and being like, I wonder, can I break it? That's always my goal. Can I break it? What if? And I don't know. I'm excited. So our denominator is a hot, stinking pile of garbage, but our numerator is still a hot pile of stinking garbage too. Theoretically, right, my numerator is now, I'm going to put the limit. Look at me being so good. There's so much mess down at the bottom. I'm going to bring that back once I've confirmed that my numerator isn't too nasty for me to be able to deal with it. But now my difference of squares is not so bananas. Now my difference of squares actually works out because I have square roots. So I end up with x plus h to the cubed, minus x cubed. And I cry a little bit because I also don't like cubes. I don't like expanding them. I don't have them in my brain like I do this, you know, the binomial, though it's not hard. It's in Pascal's triangle. So this is x, and this is why I'm really thankful, by the way, I didn't include any sort of coefficient. X cubed plus 3xh. I'll make the square there. That doesn't look in the right place. It's supposed to be on the x, but I put my x too close to my h. Squared h plus 3xh squared plus h cubed minus x cubed. That's that whole numerator. And look at this magic. The x cubes cancel. I can pull an h out of each of that, and I am off to the races. Okay. I'm going to shove it here at the bottom. It's going to be a mess. But I'm going to do it, because otherwise I'm not going to remember all this. And then maybe I'll take a screenshot. Oh, that's an x, not h. Maybe I'll take a screenshot as I move to the next screen. Okay, so my numerator, I'm going to go ahead and cancel the h from the mess out. We know there was an h there. I hope you're okay with that. So this is going to be 3x squared. Come on. The next one is going to be a plus 3xh. We got rid of one of the h's, and plus an h squared. It's not going to matter. H goes to 0, so, you know, that's all nonsense anyways. Now is the nasty part. I need to pull all the mess that I got rid of, right? So I already canceled the h. Don't need that anymore. I do need that first gnarly conjugate with the fourth roots. So I'm going to bring that guy back over. We've got a fourth root of x plus h cubed plus a fourth root of x cubed. We also need our second conjugate that we multiplied by, because I had to do this twice. Still am feeling good that it actually worked. And so we have our square root of x plus h cubed plus cube root, or square root of x cubed. Cool. And now we no longer have our 0 over 0 because we canceled that h. So we can plug in 0 for h, which is going to give us some magical things, right? We end up with just a 3x squared in our numerator. That's feeling good because at least we see the 3 from my power rule, right? I'm going, okay, something didn't get too screwed up, maybe. We still have yet to see if I can pull this all off. In our denominator, we have a fourth root of x cubed, right? Dun, dun, dun. Plus a fourth root of x cubed. The h went to 0, so those are now identical. And this is times the square root of x cubed plus the square root of x cubed. So we've accomplished the limit definition. The real question is this the same as what I had from the power rule? So let me screenshot this and see if I can do some simplifying to get back to where I'm hoping I didn't make any errors. So, ooh, that's humongous. Thank you. And let's go ahead and screenshot our final answers. I don't know which one's going to be best. I'll just grab all of them in my screenshot so that I have a giant pile of possibilities here. That's the hardest part sometimes. It's like, which of these is it going to look like? All right. So we have identical terms here. So we can at least rewrite this as 3x squared all over 2 fourth root of x cubed times 2, square root of x cubed, right? Combining like terms. That's it. That's all I did there. So these became 2 of that. There was addition, and that became 2 of that. And so again, I'm getting a little pat on the back. I know my answer has a 4 in it, and I'm seeing the 4. Yeah. All right. So let me rewrite this using my fractional or rational exponents because it's going to make life a little bit easier on us. We have a 3x squared on the top. I'm going to go ahead and multiply the 2 and 2 to 4. As I said, I'm excited about that. And then we have an x to the 3/4 and an x to the 3/2. So we can just use exponent rules. This is 3/4, and we're going to have x to the 2 minus 3/4 minus 3/2, right? I'm just going to subtract off those two denominator exponents because I don't want to think anymore. Oh my God, it hurts. It hurts. I've done too much math. I'm going to just calculator this because I don't want to think about it. Don't judge me. This ends up being 3/4 x to the negative 1/4, which was the one version I didn't bring over. It's at the top. But we are in the exact same spot. We found it. This is just another way to write that. Was that a necessary 15-minute video? No. Did I have fun doing the math in that video? Yes. And did I get discouraged? Like, I just want to point out, as soon as I realized that I had fourth roots and my conjugate wasn't going to do what I wanted, I was like, let's try it. Screw it, try it anyways, let's see what happens. And then I was like, ooh, I can see some square roots happening, and sometimes you won't get there, and that's fine. But sort of being willing to travel down a rabbit hole, not knowing if it's going to get you where you want to go, is the sign that you're having fun and being entertained with your math.